Should I start, ma'am?
Yes, ma'am. Yeah.
Yes. Okay.
Respected Principal Dr. Subhash Shinde, sir, Head of Computer Engineering Department and Dean Academics Dr. Shiba P.S. ma'am, Head of AIML Department Dr. Chaitali Chaudhary ma'am, experts, deans, and all the participants. Good evening, everyone. On behalf of Lokmanya Tilak College of Engineering, Navi Mumbai, and the Departments of Computer Engineering and the Department of Computer Science and Engineering, AIML, I, Dr. Rakhi Akhre, Program Coordinator of this extend of warm and heartfelt welcome for this FDP AICT ATAL 1 week online faculty development program on India's global development in the digital age, ensuring security in cyber physical systems for a resilient future. To begin today's inaugural ceremony on an auspicious note, let us invoke the blessings of Goddess Saraswati, the embodiment of knowledge, wisdom, and learning. So let us proceed for the Saraswati Vandana.
वृता या वीणा वरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीमभयदाम् जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्
Thank you. Thank you for the beautiful invocation. To officially open today's inaugural session, I now request Dr. Chaitrali Chaudhary Ma'am, FDP Coordinator and Head of Department CSC AIML, to address the gathering.
Thank you, ma'am. Good evening, respected Principal Dr. Subhash Shinde, sir, Head of the Department of Computer Engineering and Dean Academics and Research, Dr. Shiba PS, esteemed session experts, deans, and all our enthusiastic faculty participants. On behalf of Lokmanya Tilak College of Engineering, Navi Mumbai, and the Departments of Computer Engineering and CSC AIML, it is my privilege to welcome you all to the AICT ATAL 1 week online faculty development program on India's global development in the digital age, ensuring security in the cyber physical systems for a resilient future. I'm Dr. Chaitrali Chaudhary, FDP Coordinator and Head of Department of CSE AIML, and it gives me immense pleasure to address this gathering as we begin this important academic initiative with the objective to empower educators with the ability to understand, implement, and teach the next generation of intelligent and decentralized technologies. India is witnessing rapid advancement in the digital technologies from smart cities to automated transportation to secure medical systems, etc. All of those are powered by CPS, which blend physical processes with computing and communication technologies. However, with this tremendous growth comes the equally significant responsibility of ensuring security, resilience, and trustworthiness in these systems. Hence, this FDP is structured specifically to create awareness, build foundational understanding, and encourage research-oriented thinking in this engineering domain. The FDP includes fundamental sessions with conceptual grounding, technology-oriented sessions for practice exposure, and use case discussions with industry relevance, along with research-oriented modules for academic enhancement. Through this week-long program, participants will gain insight into CPS architecture, design, and real-world applications, vulnerabilities and security challenges across the sectors, national and global standards for CPS, India's contribution to global digital environment, approaches towards building resilient CPS, and opportunities for interdisciplinary collaboration. We are privileged to host experts from academics as well as industries who will guide us throughout these 6 days. I sincerely hope that all the participants find this FDP insightful, interactive, and impactful. Wishing you all a fruitful learning experience in the coming week. Thank you very much. Ma'am, please unmute.
Thank you, Tetali ma'am, for your insightful and inspiring address. Now I would like to invite Dr. Shiba PS, Head of Department of Computer Engineering, to share her thoughts. Dr. Shiba PS has been a driving force behind academic excellence in our department. Her guidance and support have played a significant role in shaping the vision of this FDP. Ma'am, I request you to address the gathering.
Thank you, ma'am. Respected principals, sir, FDP coordinators, distinguished faculty colleagues, invited experts, and all participants. A warm welcome to each one of you. As the co-convener and head of the Computer Engineering Department, it is a privilege to address you today as we begin our program on India's global development in the digital age, ensuring security in cyber-physical systems for a resilient future. India is moving rapidly toward becoming a global digital leader with initiatives like Digital India, Smart Cities, Make in India, BharatNet, and India AI. Our nation is not just adapting to global change. We are contributing to it, shaping it, and leading it. At the heart of this remarkable journey lie cyber physical systems, the intelligent frameworks that power our industries, protect our citizens, and enable innovation at a scale the world is beginning to acknowledge. But with progress comes responsibility, and with connectivity comes vulnerability. The future we envision for India, a future that is smart, secure, and globally competitive, will depend on how effectively we protect these interconnected ecosystems. As educators, researchers, and professionals, we stand at the front lines of this transformation. This program has been crafted with a vision to ignite curiosity, strengthen foundational understanding, and inspire new thinking. Our goals are clear. First one is to help participants gain deep insight into the architectures and opportunities of cyber physical system. Second, to build a strong awareness of security challenges, enabling us to design systems that are safe, resilient, and trustworthy. Third, to encourage research, innovation, and academic leadership so that our institutions become contributors to India's digital growth, not merely observers. We are honored to host experts who will share both academic and industry perspectives. I encourage all participants to actively interact, explore collaborative ideas, and embrace this platform as an opportunity for academic growth. Let us learn not just to keep pace with the digital age, but to shape it with purpose and integrity. Let us remember the strength of a nation's digital future lies not only in technology it creates, but in the people who understand, safeguard, and advance it. Today, each of us has an opportunity to be part of that future. I wish all participants an inspiring and transformative learning experience. Thank you all. Thank you. Over to you, ma'am.
Thank you, ma'am, for your valuable words. It is now my privilege to invite our respected principal, sir, Dr. Subhash Shinde, and chief patron of this FDP, a leader who consistently inspires and motivates us towards academic excellence and innovation. Sir, I request you to deliver the inaugural address.
Thank you, ma'am. Ma'am, I'm audible?
Yes, sir.
Okay. Very good evening to everyone present here. On behalf of Lokmanya Tilak College of Engineering, I extend warm welcome to the resource persons, co-convener, coordinators, FDP team members, and all the participants who join today us for this the faculty development program. It's my honor to the part of the inaugural sessions of this the ATAL sponsored faculty development program. In today's Industry 4.0 era, emerging technology such as artificial intelligence, machine learning, blockchain, and many other plays an important role in transferring the industry and the society. However, for the many complex real-world problems, the existing technology or the techniques may not always be sufficient. This is where the academicians and the researcher must contribute by developing the improved ideas and innovative methodology and the advanced algorithm. And so such a progress is the possible only through the collaboration, interactions, and the continuous learning. Programs like this FDP serve as an excellent platform for exchanging the knowledge, exploring the research ideas, and strengthening the academic ecosystem. I sincerely appreciate the efforts of Dr. Chaitali, Dr. Rakhi ma'am for designing the organizing this FDP with a great dedication. I'll also like to thank the AICT for the sponsoring this the program. I express my gratitude to all the management for their the constant support and the motivations. I am confident that at the end of this the FDP, each participant will gain the meaningful learning and the valuable insight. I wish you entire the program great success. Thank you.
Thank you, sir, for your motivating and encouraging words. With the blessing of divine and the guidance of our dignitaries, we now proceed to our first technical session of the day. Before we begin, a few important announcements for all the participants. Attendance is mandatory for all sessions. Attendance is mandatory for all sessions as per ATAL guidelines. A test will be conducted on the final day. Participants must clear the test and submit daily feedback for certification. Please remain muted during the session and post your queries in the chat box. I now hand over the session back to our esteemed expert speaker, Dr. Subhash Shinde, to begin today's session.
Yeah, ma'am. Give me 2 minutes.
Sure, sir. We'll start the session after 5 minutes. Yeah. And continue session 1. Okay. Participants, please wait in the meet for 5 minutes.
Ma'am, my screen is visible?
Yes, sir.
Sir, your screen. Okay. Yeah. Now it says.
So before starting, I just introduce today's expert. Yeah? So please give me 2 minutes. Hello, Shinde sir.
Yes, ma'am.
Please wait for 2 minutes. I'm just introducing yourself. Okay. Okay. So today's expert speaker, Dr. Subhash Shinde sir, has accomplished computer engineering, is the principal and professor in computer engineering at Lokmanya Tilak College of Engineering, Navi Mumbai. He has completed his BE in computer science and engineering, his ME in information technology, and his PhD in computer science and engineering. He has more than 25 years experience in the field of academics, administration, and research. He has published about 80 papers in the international journals and conferences. He has filed 3 patents, 4 copyrights to his credit. He has also authored 5 books through reputed publisher. Under his supervision, 10 research scholars and 33 postgraduate students have successfully completed their degrees from the University of Mumbai. Currently, he is Chairman, Board of Studies in Computer Engineering under the Faculty Science and Technology, as well as a member of Research and Recognition Committee. Also, he is a member of RRC at SNDT University, Mumbai, SRTM Nanded. He has worked as a chairman, Board of Studies in the Computer Engineering under Faculty of Technology, University of Mumbai, and member of Academic Council, BUTR, RRC of University of Mumbai from July 2015 to September 2019. He has also contributed as a member of Board of Studies in Information Technology under Faculty of Science and Technology, Pune University from July 2015 to August 2019. He is a life member of IST and Computer Science Society of India and also International Association of Computer Science and Information Technology. He is a reviewer for reputed journals like IEEE Transactions, Science Direct, and Springer. Recently, he has honored with the Best Principal of the Year award from London Business School. Thank you, sir. Please continue with your session.
Thank you, ma'am. I'm audible?
Yes, sir. Yes.
Okay. Welcome you all in the first session of the faculty development program. Today, I'm covering the overview of the cyber physical system. This is the outline for the today's presentation. Quickly, I introduce about what's the concept of the cyber physical system. Then we'll discuss application of the cyber physical system, characteristics of the cyber physical system. The more aspect about we'll discuss what's the architecture and the component of the cyber physical system, how we can do the modeling, and the research trends in the cyber physical system. At the end, we can see one case study that is called as the thermostat for the effective cyber physical system. We'll discuss how exactly we can design that one. Before we move into that, the cyber physical system, let's understand the computing revolution. So the next computing revolution shift from the mainframe to the cyber physical systems. Initially, the computing revolution start with the mainframe systems. Then it's landed into the cyber physical system. So the mainframe computing, it's coming to that the 1960 to the 70. Prior into that, when the 2 generation of the computers presents. So the first generation, which into the 1940 to 14 to 50, where you are aware there are the vacuum tubes are the use, the magnetic drums are the use, and that computer are so much bulky. Then into the next generation, so these are the limitations are overcomes. So that the next generation, that is called as the second generation, into the 1950 to the 1960, where the vacuum tubes and the magnetic drums that are replaced by the transistor. And into that second generation, the high-level language like as a COBOL, Fortran, that were that introduced. Also, we got that time that's concept of the multitasking, multi-programming. The advantage of this, the second generation, that reduce the size of the computer, and also the one limitations that coming into that one at the same time, so many programs we cannot run into that the second generation. And that limitations overcome into the 1960 to the 1970. That's called as the mainframe computing. The mainframe computing where the integrated circuits are used, which supports for the multitasking, multi-programming, multi-user operating systems. And from the 1960 onwards, the computers are used for the business purposes. The super powerful centralized computer system, they built it for the massive data processing applications. Then the era of the internet start from the 1980 onwards. So in this the era, so the one computer at every desk to do the business. That concept come, that is called, or maybe for the personal activities. So then that is again the revolution happen into the computing. The computer makes into the again the smaller size, and the many applications that's come into that in the desktop computing. Then from the 2000 onwards, the concept of the ubiquitous computing comes. It is also called as a pervasive computing. The numerous computing devices are placed into the different domain, and they can interact with each other, and that's completely invisible to the users, and it's completely invisible into the environments. So the typical example, if you see into that one, the smart home, where the different objects are the present, different devices are the present, they are connecting to each others, but it is completely invisible. However, when this ubiquitous computing works, there are some limitations. The limitations, the one is called, that is called as the context awareness. So whatever the devices are the present in this the ubiquitous computing, they cannot adopt the behavior as per the surrounding conditions. That's the major limitations. It's come into that the ubiquitous computing. Also, to scale up the range, that's the ubiquitous computing also struggling. The energy consumption is also the one problem, and the one major problem is the concern with the security. And these are the motivations to come into that the next revolution, and that is called as a cyber physical system. So the cyber physical system is developed by the great scientist by the Helen Gill into the 2006 in the National Science Foundation in the USA, but actually the system is built into the 2010. And from that, the concept of the cyber physical systems come into the existence. So we always call into that the mother is the necessity of the invention is mother of the necessity. Then when you come into that, the inventions, what is the basic goal behind into that one? So the basic goal of the cyber physical system is to transform how to interact with the physical world. So the fundamental goal of this one is to interact with the physical world. And when you interact with the physical world, that the physical entity, that physical devices, that can work as per the atmosphere changes. It is the fusion of the physical and the computation science. Cyber physical system creates a physical fusion of the physical and the computation science. Physical means the devices, sensor, actuator, these are the physical devices. And the computer science, computational science, it's work into that doing the computations, where the artificial intelligence comes, machine learning, it comes, the data science will becomes. So it's all integrated by the cyber physical system. Ultimate goal to produce the significant impact onto the society for developing an efficient and intelligent system. So that's the ultimate goal for the cyber physical system. Then what is the new into the cyber physical system? Because when the any new techniques or any new invention comes, at that times, what are the new technologies or what are the new features supposed to be there? The first is coming to that. Openness is the CPS systems are open to interact across the diverse domain. If you see the previously in the ubiquitous system, or we call it as the pervasive system, the more are you are stick into the one environment. If you talk about the smartphone, you're talking to the smartphone environment into that one. If you talk about the robotics, it's talk about the robotics only. But when coming to that, the cyber physical system, the smartphone connect to the robotics, smartphone connected to the smart homes, then these are the intermediate domain that we call as the heterogeneous is the one nature into that one, that is called as openness. The openness is integrate across the diverse domain. Second, the feature of the CPS is the scalability. The CPS work into the massive scale. If you talk about the pervasive computing or the previous technology, its range is the limited. But when talk about the CPS, the range is not limited. The number of sensors, number of actuator, number of users, there is no limit for that one. So world cover the trillion of sensors or the actuators or maybe into that the users to use that the CPS. And it is a systems of systems. Previously, a system is one system that's called as one autonomous system. But when you talk about the CPS, it is a systems of systems. The best example is called as a smart city. In the smart city, one system which taken care about the weather report. One autonomous system is taken care about the transportation. One autonomous is a grid computing. And so all these autonomous systems connected together, then it is called as a one cyber physical system. That name we can give as called as a smart city. So the CPS is a system of systems. CPS is a confluence of the physical, wireless, and computing. So here we have merged the physical, wireless, and the computing. The physical, the devices we can integrate with the wireless devices, as well as we are doing the computing onto that the physical devices. And the very important into that one, the cyber physical system is the human participation, the human into the loop. If you see into that, the previous the technology, if you talk about the ubiquitous or maybe as a previous technology, at that time, the human is not the actively participate, not directly or the indirectly. But here in the cyber physical system, the human is plays the important role into the participation. The best example of this one is called as the robotic surgery. The robot doing the surgery, but at the same time, the doctor also into the loop. So that's the beauty of the cyber physical system. There are the many definitions of the cyber physical systems. So in the different books, they are given different definition. In the different journals also have the different definition. But I think this is the most appropriate definition, which I have taken from the IEEE Computer Magazine. The definition is the cyber physical system is a co-expression of computer, machines, people for achieving the goal using the techniques like the computation, communication, and the control. So cyber physical system is arrangement of the computers, machine, and the people to achieve the specific goal. And they are using the techniques like as a computation, where the inputs are converted into the some desired output, some the logic is happen behind into that one. So the communications, the inputs is going to the proper place with the proper communications. And the very important is the control. The system is work into the feedback. So this cyber physical system work with the feedback system. That's why the control plays the very important role. So as already I mentioned into that, the CPS is an interdisciplinary domain. There are the many domains comes together in the cyber physical system. So when you talk about the ubiquitous computing, pervasive computing, or many another into that, the IoT, or these are the unique domain into that one, or you can talk about the image processing or the image binding. So they are talking about the specific domain. But when you talk about the cyber physical system, it is the interdisciplinary domain where the role of the computer science and engineering is present. So which is the brain of this, the cyber physical system, where the logic is developed, where the scheduling is comes, where we can give the security to your the systems. Next one is talk about the control system. So it is a complete the feedback system. As per the feedback, the systems work. The communication and the networking. So the communications, the standard protocols are the use different types of the sensors we are using into that one. Then the physical and the mechanical systems, where the actuators, the different objects is connected to the different sensors. So that's it come into the physical and the mechanical system. So this particular the diagram shows how the CPS is involved the different domain. So this is the typical ecosystem of the cyber physical system. As already I mentioned, so different domains works into the cyber physical system. then how the ecosystem works. So these ecosystems work into the two phases. The first is come into that the sensing, and the next one is called as the actuations. Since the sensing and the actuations, these are the part of the transistor. So that is the sensor and the actuator. These are the types of the transistor which convert the signal one form to the another forms. So the sensing is happen through the sensors. The actuation is through the actuators. So let's talk about the cyber physical ecosystem is divided into the two parts. One is the cyber, next one is the physical. So what is happening into the sensing? Sensing is the eyes and the ear of the systems. Sensing is the eyes and the ear of this the cyber physical system. So sensing takes the input from the any objects or from the plant or from the system, and it gives to the controller. Controller is nothing but here it is happening, you are the computational. Here the computational is happening through these the control microprocessor, or maybe into that one, any the control devices who can do this the computational part. And the next, the outcome of these, the controller is given to the input to the actuation, which is the muscle of this the cyber physical system, which convert the binary into the physical action. So whatever the electrical data or the binary data when you receive from this the controller, and whatever the input is coming from this the controller or the computations, it's converted into the mechanical action, and these mechanical actions change the motion of the system or the plant, and this is work into the total feedback system. So the fourth is it is the invisible, but the feedback system work into that one. So like that, the sensing, controller, actuations, these are the ecosystem work in this the cyber physical system. Typical example you can see into that the robot. Robot sense the data. Suppose there is some sort of the inputs. Suppose the robot wants to change the arms. So that actions, that sense is given through the sensor. Sensor gives to the controller. Controllers do that the computations and give to the actuators, and the actuator change that particular the action of that the robot arms, and like that the system can be worked. So that is called as a sensing, controller, and the actuation. In the cyber physical system, the computational, communication, and the control, it's integrated very deeply. Another, I'll give you the one typical example how these the cyber and the physical system work. The upper part is the cyber, and the lower part is called as the physical. The cyber part is also called as a logical, where the computational and the communication is the happen. So let's take the typical example of this one. One of the physical state or the physical state is P, which having that the values like as a P1 to the Pm. So these inputs are sensed by the some sensors. And these sensors, this input is given, which into the form of the that's into the sinusoidal or into the different forms, and the sensor convert that into the binary form. And this binary, it's given to the some the microprocessor or the microcontroller devices here. So what doing into that? So the input of the P1 to the PM is converted to the L1 to the Ln. So this is come as a logical state, and this is given to the computational part. And some of the computation is happen here, and after that the logical state changes to the L1 dash to the L1 dash. This is the dash over here. So these are the outcome, these are the output of the logical state, and these outputs is again used to the actuators. And when these actuate given to the output logical state, and its changes is the physical state, that is called as the P1 dash to the P dash M. So these are the changes the logical state from the P1 to the P dash. So these are the changes is happening into this the ecosystem. In short, so this the integration of the computational and the communication and the control is happen so logically and integrally into that in the fraction of second. So this all the computations is happening, and the changes is happen into the physical states. Now we'll discuss about some of the applications of the cyber physical system. So the first application of the cyber physical system into the transportations, especially into the aircraft. CPS allows for the aircraft with the faster, safer, and the more energy efficient. CPS also plays the important role, especially for the aircraft, for the energy consumption. Also, CPS plays the important role for the safety point of view also. CPS plays the important role for to manage the traffic. The traffic control is also taken care by the CPS, so it can navigate to the users or maybe into that one the pilots. So far related to the traffic. So next one is coming to that the autonomous unmanned drones. You already familiar about that one. How the drones are used now into the army, into the, in the agriculture sectors. So now all the wars are happening through the drones. So why these drones are used? Because the drones are so precise, they can hit that the locations. And one more important part into that one, the drones, they can manage the traffic. In the 1 second, suppose you fire the 100 drones. So this drone also manage the traffics. They can control the scheduling and they can hit to the targets. So that also controlled by the cyber physical system. And in this one, the human interface is there. As already had clear, the previous system, the human interface is not there into that one, but here, especially when talk about this one, it is completely automated, but there is the control of the human interface. The second application of this autonomous car in the transportations, the autonomous car, the basic objective to develop the autonomous car is the safety and the security, and the very important is the control. To reduce the number of accidents, these autonomous cars develops. Actually, right now we are in the era of Industry 5.0. So we are talking about the Industry 4.0, but already Industry 5.0 already started, especially in the Japan. So they are typically used is the concept of the cyber physical system in the transportations as well as in the medical system, in the medical healthcare. And they are used this technology solve the complex problems. So if you see here in the autonomous car, very few countries they are using this complete autonomous car, especially in the India. We are not come into that the complete fully autonomous car that is called as the driverless car. But in some country now they are working into this completely driverless car, which is called as autonomous car. The CPS also helps in this autonomous car for the connected the vehicles, because all the cars are the driverless. Now how to control for that one? That is called as the concept V2V, vehicle to vehicle. That is one ad hoc network is created into that one. Next also called as a V2 infrastructure. That is a vehicle to the infrastructures. And one more into that one, the V2 cloud. So these are the different types of the autonomous, or we call as ad hoc networks are created. Through that, all these driverless cars are connected to each others. Also, the CPS helps for the autonomous car for the ride sharing. Also, the helps for the traffic management. Then one more, the basic, as already I clear into that, the basic motivation of this autonomous car is to reduce the accident. But at the same times, when you work with the driverless car or the autonomous car, some ethics supposed to be maintained. So the ethics into that one, how you effectively use the concept of the cyber physical system, because somewhere you can hack the many parts of the autonomous car, the driverless car. Someone unethically control the engine, unethically control the steering. They try to do some sort of the illegal activities to happen the accident. So that illegal practices not supposed to happen. So that is a complete domain that is called as the ethics of the driverless car. So just I have put it on the picture. When the concept of this autonomous car is coming, at the same times the ethics of this autonomous car also works into the parallel, because the technology when come into the public domain, at that times there are some concerns related to the security. And the concern is supposed to be take care, and to stick to that, the concern to the security, some ethics supposed to be followed. So that it's coming into that, the ethics of the driverless car. The next applications is the grid computing, how to efficient manage the energy. That's again the important applications of the cyber physical system. The cyber physical system plays the important role for the smart buildings, for the efficient energy operations. Also, the CPS used for the smart home. In the ubiquitous computing, the homes are not that much the smart home. But now that the limitations are overcome into the cyber physical system, especially when talking about the smart home connected to the smart cities. In the smart home, it is not related to control the light, fans, or maybe into that the security. But in the smart home, it's controlled to you in the fridge, in your as well as your washing machines, each and every that are controlled, and that devices work as per the atmosphere. For example, if there are the more people, so the heating will be that air condition will be the less temperature. When there is no one into that one in the room, automatically light off. So that's all the things are taken care into that the smart homes. So that's one of the great applications. And in the few countries, they are using that the concept of the smart home, and the smart homes are connected to the smart cities also. Also, the CPS are used for the EV charging and the solar roof panels. So in our country also, we are using the CPS for the solar roof panels. The CPS also helps for the microgrid. It is the reliable and the resilience of the electrical grid. How to make it reliable and the resilience, that's you can take through the CPS. Then one more into that one application, which is very important when you talk about the cyber physical system. So that is the healthcare and the biomedical. In the healthcare and the biomedicals, the cyber physical system work into the 3 layers. One is called as a physical, next one is called as a computational, and third one is called as a control. The physical means where the medical devices are implanted into the human body. Let's see, these are the different health and well-being monitoring devices. There are some sensors. There are some other devices which can monitor your health. So these devices are implanted into the human body for the health management system. The first is the physical domain. The next is the part about that is called as so let's see into that one. These are the devices, for example, cardiac. Next one into that one, there are the different implant that we call as the medical devices into the body. And these the devices when implant into the body, the next concept is called as a computational. The computational happen onto the local system, or maybe into that one, into that the cloud also. I'll talk about much more about that one, that is called as edge computing and the fog computing. What is the concept of that one? But let's right now here you consider when the inputs are taken from the body, and that inputs are given to the somewhere into the computational center. Let's here in that case you see into that one on the cloud or into that one server, where the one EPR is present for the every human body. Electronic patient record is the present. So in that electronic patient record, so the doctors are monitoring into that one. If there is different changes into that one into the body, or some infection is happening in the body, so this EPR, electronic patient record, that can show some visualization, and that is happening some visualization there. Ultimately, that is recorded by the doctors, and they can ask to the patients take some medicines, or some major they can admit into the hospital. So the healthcare systems work into that typical 3 layers. So first is related to the physical domain, next one physical layer, next one is called as the computation, and last one is the control. Control means if there is requirement into that one, they can admit, or the doctor is human being, human participations into that the CPS, they can monitor into that one. If they require ask for some medical treatment, or if some sort of the emergency, they can ask to that the patients to admit into the hospital. So like that, this is the healthcare systems work. So next, there are the many applications into that one. I'll not describe, so I'll not explain much more the next application. So the water and the waste management. This is again the typical application of the cyber physical system. I'll give the best example of this water and waste management into the Indore. Indore, beautifully, they develop this water and waste management, and because of that one, there are municipal corporations is first since last 5 years throughout in the country. So because of this, the cyber physical system, they develop very systematically water and management control. Then the health monitoring. So already I had discussed into that one. So this is regarding to the structure health monitoring, especially for the infrastructure, civil engineering. Also, the CPS used for the gas, electricity, and the utility of the infrastructure. Also use the agriculture's manufacturing and the industrial control. So the like that, many more applications we can do through the cyber physical system. Now the next part of the presentation is component of the cyber physical system. As already I had cleared, the cyber physical system is interdisciplinary. The many domain knowledge is required. And considering that one, when you're developing any cyber physical system, so we require the minimum, these are the 5 components. The very first is called as a sensor. So there are the different types of the sensors. So active sensor, passive sensor, analog signal, digital signal, scalar sensor, or maybe as a vector sensor. And this sensor, which type of the sensor we have to take, it depends on to the application. What type of the input and what type of the output you have to generate. Considering that one, you take such type of the sensors. And these sensors, when you choose, for example, if you talk about the healthcare, so if you see into that example, there are the different types of the sensor. If you talk about the temperature, that is called as the PID sensors to measure as the temperature. So then the PID. So different types of the sensor you can choose as per your the applications. Which type of the inputs, and you have to convert the which type of the outputs. Then the next part is coming into that, the data computing. So what's coming into that, the data computing? So computing means we are doing some of the computational part there, where the mathematics also comes, as well as the algorithms also comes. Here, the basic mathematical model also plays the important role. What type of the inputs, how many the outputs supposed to be there. At the same time, what is the logic behind that one? For example, which type of the artificial intelligence algorithm we are using? For example, some machine learning algorithm, reinforcement learning, or some pattern recognition algorithms, or some scheduling we have to do, that is called as a job scheduling. So that all are the part, that is analysis of algorithm. Everything that's come into the here, that's called as a data computing. The next is coming into that one, the network and the communication management. Network and the communication management. So specific architecture we require, that is called as the network architectures, where in the each layer the different protocols, and that how the protocols are communicated between source to the destination, that is called as the network communications management. And the actuators, so this is again one of the device which convert the electrical or the binary signal into the physical actions. So like as a wall, which take the input as electrical signal and convert it to the wall on and off, that is called as actuators. So these actuators, different types of the actuators are the presence, and these actuators you're supposed to be taking care. And the last one is called as the data storage. So we are storing the data, and that data maybe onto the local system, or maybe onto centralized system, or maybe into that in between into that one. So that the data storage, how much data we can store. That is another important component of the cyber physical system. And when you're developing any particular the applications, so these are the components we require into the system. And when you are working with the cyber physical system components, at the same time, there are the different risks or the attacks also present. So that's we call as the cyber threats and the vulnerabilities. When you work with the components, so the different types of the attacks and the vulnerabilities are take place. For example, when you talk about the computing, the more threats or the attacks is for the information leakage. So the information leakage, where some of the hackers can take the unauthorized access and they can leak the informations. Enforced computing errors, where some malicious computing happens, or whatever the computing is happen, that goes somewhere in the wrong directions. And next one is coming into that, the timing errors. So in the cyber physical system, the computational should be in the real time. If there is some delay into the computations, then definitely the action goes where the wrong. And the hacker take care about that one. You are the timing errors supposed to be happen. They're taken into that one. The outcome of that the computational devices is not happen regularly. They put some control onto that one. That's called as the timing error. When you talk about the communications, what are the different types of the attacks or the threats possible? For example, the packet modifications, man in the middle attack, resource blocking. So these are all the attacks you already aware into that one. Such type of the attacks can be work onto these the communications. If you see in this one, so if you see in the resource blocking, this plays into that one into the network. Because many times to block the resources can be used by some other persons, and because of that the communication is not happening. So that's many times you can see. So but in the cyber physical system, so if such a things are happening, you have to take care about how you can unblock the resources or some other resources, how you can give it into that. When talk about the actuators, here the authentication failure and the deadline mess. So the authentication failure means performing the actions into that. Whatever the actions we are performing onto the actuators, that's supposed to be not performed. So by the authentication failure, that may be caused into that one. And the next one into that, the storage modification, whatever the data is present, that can be modified the data, especially into that one, the medical field, when the patient data, electronic patient is happening, and to provide that the security, you have to find some another solutions. Same with the sensor spoofing and the denial of services. So these are the attacks can be work. So whenever if someone wants to give some better solution, so here we have to work onto these threats or onto these are the problems related to the cyber physical system. If you to give the solution into the one part, for example, information leakage, packet modifications, and then it is called as a deadline miss, storage modification, and the denial of service. And if you're developing one, so that's one called as a new cyber physical system for any applications. For example, you're building as a smart home, or if you're building as some robot. At that time, if you're taking care about these type of the challenges and you are giving the solution, definitely it is one sort of the contributions. Because as already I mentioned into that, when the cyber physical system, the existing algorithm cannot work. The existing algorithms cannot give the precise solution into that. So here we have to need into that some the better solutions. Because here the heterogeneities work. In the heterogeneity, the parameters are the different. The existing algorithms, maybe as a machine learning algorithm or maybe as a deep learning, they are struggling into that. We have to modify the algorithms as per the applications and to give the solution all these the problems which I discussed now. So these are the threats and the vulnerabilities of the cyber physical system. So when you develop as a complete cyber physical system, what are the features supposed to be there? What are the characteristics of the cyber physical system? One second. The first characteristics of the cyber physical system, it's intelligence and adaptive business. When we discuss about the previous system, because always I've given the example of the previous, that is the previous revolution, that is the ubiquitous or the pervasive computing. Why given? Because some changes is happen from the ubiquitous computing to the cyber physical system. Previously, system is not the adaptive. What is the concept of the adaptive is it take the decision without the human interface, as well as it's adaptive to the uncertainties. So previous system is not able to adopt the uncertainties. The system the pervasive computing work into the one standard patterns. If there is some sort of that uncertainty of some of the change in the environment, the system it's not adopt. But when talk about the characteristics of the cyber physical system, the very first one is called as adaptive. It can adopt the environment. You take the example of this autonomous car or the driverless car. When the driverless cars, when the car is moving into that, when some sort of the obstacles comes, so that obstacles is sensed by the sensors, and according after that, when engine take the actions into that one, they change the path, change the route. So that is not happening into the ubiquitous computing, and that's the important part into the cyber physical system. Next one is come as intelligence. Sometimes the human interface is required, sometimes human interface is not required. Seeing the conditions, the cyber physical system is supposed to be work. Showing the intelligence, seeing the previous experience, the cyber physical system work. So in the cyber physical system, one important part is called as a control system, which work into the feedback system. Whatever the feedback is present previously, according to the feedback system, much more intelligence. The concept of the reinforcement learning is works into cyber physical system. So the cyber physical system is intelligence and the adaptive business. Next one is the real-time operations. Cyber physical system should be without delay. The continuous sensing of the data, continuous operation supposed to be happen. For example, you take the example of the smart gate, or the next one is called as the autonomous car or the driverless car. The operations are continuous. From the steering to the engines, from the engines to the all places. So it's happened the real-time operations. You take the example of the any manufacturing system where the real-time operations work because the job is continuously work for the 24 hours. So the real-time operation is need. Connectivity and the communications. So here the two new concept will become, that is called as edge computing and the fog computing. I'll talk later into that one, edge computing and the fog computing. Right now, here we just understand the connectivity and the communications. The communication supposed to be happen so quickly. And the next one is the connectivity. The connection should be the very much secure. The connecting the one points to the another point is very much secure. Connect is supposed to be the happen, maybe wired, maybe wireless, and the communication with the fraction of the seconds. For that, the new technologies come, the edge and fog computing. I'll discuss later into that. What is the concept of the edge and fog computing? Also, the concept of the IoT also used into the some applications, but with some application, the edge and the fog computing is required, especially for the medical field or maybe into that the manufacturing field, because there the transmission delay should be minimized. So at that times, we require the edge and the fog computing. And the very last characteristics of the CPS, the system supposed to be safety and the security. Whatever the operation is happening into the cyber physical system, it should be safe and the secure. Because ultimate goal of the cyber physical system, make it is life simple. So when you make it as a life simple, at that times the safety plays the important role, and the system is supposed to be much more secure. So when you're developing the any cyber physical system, so maybe for the transportations, maybe for the medical, maybe for the energy consumption, or maybe for the any application developing, maybe for the agriculture. So these are the characteristics supposed to be present: intelligence and adaptive business, real-time operations, connectivity and communications, and the safety and the security. So we discuss about what are the applications of the cyber physical systems. Then we see the components, what are the vulnerability of all those components. Then you see we are discuss about the characteristics of the cyber physical system. Now we'll come into that one. The cyber physical system is why so hard? Because as already I clear into that one, it is the interdisciplinary domain. Cyber physical system is the completely interdisciplinary domain. There is happening computing, control, and the systems. So when talk about these, the computing, control, and the systems, the main part is the disciplinary boundaries need to be realigned. Because when you see into that previous ubiquitous or as a traditional system, the boundaries are very defined into that. That is the one system when you talk about the, especially the ubiquitous computing, when you talk about the controlling the weather. Okay, this controlling only that particular the applications. But when you talk about the cyber physical system, take the example of the smart city. In the smart city, we require the power, we require the transport, we require into that the scheduling, we require the weather reports. The so many the autonomous systems are the presents which are the different in the natures, and that we have to combine together. And that's one of the difficult tasks, especially when you building as a cyber physical system. So that's why the boundaries needed to be realigned. So when you connected the one autonomous system to the another system, at that times, so boundary is supposed to be clear. For example, transportations, it's one autonomous system, and the weather report. So now how you can, next one is into that the traffic control. So this is the traffic control, weather report, traffic management, how to connect it to the each others. So that is one of the difficult tasks in the cyber physical system. New fundamentals need to be created. As cyber physical system work into the interdisciplinary, the existing algorithms, the existing methodology may or may not be work. At that times, new fundamentals need to be created. New theory is supposed to be created. New algorithms supposed to be created. If we talk about the applications into the healthcare, definitely the existing algorithms not work into that, because the sensors are taking the inputs from the body, which converted into the again especially into the binary, and vice versa. The binary is converted into the some actions. At that times, the existing algorithms maybe not work into that one. You have to build up some sort of the new algorithms, new theory to handle this the cyber physical system. New technology and tools need to be developed. Take the example of the simulations. When you're doing the simulations of the cyber physical system, the different simulations we have to do it. One for the physical devices, one we have to do for the computational, one we have to do for the communications. So these are all the different simulations. Again, you have to integrate it together. So at that times, the new technology, new tools need to be developed, which can combine these together. Overall, the simulations. Because previously we're doing the simulations for one particular typical system. But here the three different simulations, three or more different simulations are work. And these all the different simulations you have to combine together. So the new technology and tools needed to be developed and need the multidisciplinary domain knowledge. When we're developing as a cyber physical system, the multidisciplinary domain is required. We require the knowledge of mechanical, we require the knowledge of the people from the electrical, the people we require from the computer, the people are required from the science also, which can explain the model mathematically well. So the people from the all the domain which are required to solve the any CPS applications. When you're developing the architectures, because when you talk about the components of the CPS, then we discuss why the CPS is hard, what are the points we're supposed to be take care when you're developing as a CPS. Then we talk about the architecture. Before talk about the architectures, let's understand what are the 5 C's of the CPS. When you're developing as a CPS for the industry 4.0, then there are the 5 C are given by the CPS. The very first one that is called as connection. The smart connections to ensure the correct data. The smart sensor with the proper specification. As already I mentioned into that the previous slides also. The communications and the networking. The communication and the networking, so this is happened through the connection. The smart connections to ensure the correct data. So the connection should be very much correct. The fraction of milliseconds also the delay, it's not supposed to be happen. The smart sensor with the proper specifications. You can imagine if some sort of the sensor into the body, how much that will be sensitive. So very proper specification of the sensor, you have to change it and you have to embed into that in the objects. So that is called as a connection. Next one is called as a conversion. So where the machine data to the meaningful informations, machine becomes self-aware. The conversion is supposed to be happen very meaningful. The different types of the sensors are the present, different types of the actuators are the present. So the conversion is supposed to be very appropriate. So there are the sensors which take the inputs as the weather converted into the binary. There are the sensors which taken the input into the some different forms, which converted into the some binary. So what type of the input and outputs we taken? So that should be the very meaningful. And the machine becomes the self-aware. So you are when doing the conversions, the machine should be self-aware into that. The cyber, the central information hub utilizing clustering and data mining. The cyber is talk about the central information hub. It's coming to that the edge computing, cloud computing, or maybe into that the fog computing also. Then also utilize the concept of the clustering of the data mining. The mining is the extraction of the hidden informations. So that's called as the data mining. So we can do the clustering of the data mining algorithms. So that can be utilized for the better proper utilization of the information in the cloud or maybe into the fog computing. Next one is called as a cognition, where the proper presentation of the information and the optimization of the process. So whatever the information we received into that one, that should be into the presentable form. Then and then we can understand what sort of the action is supposed to be present. From the computing, when the data output is given to the actuators, it goes into the proper form. Then and then the actuators take that the action. And this, when this whole process is happen, it should be the optimized. Cognition is another part into that one. You are when doing as a parallel processing or the parallel shooting, it should be the optimized parallelly. There the optimization algorithm plays the important role. And the very last one, that is called as the configuration. Supervisory control to determine the action by the machine. Machine becomes a self-adaptive. That's the ultimate goal of the cyber physical system, the adaptive. So seeing the previous experience, considering the previous experience, the system works, the machine works. So that is called as a machine becomes the self-adaptive. Here, the concept of the reinforcement learning when you're doing as a configuration. So we see the developing as an architecture. So this is the typical architecture of the cyber physical system. The cyber physical system, it's work into the typically in the 3 layers. This is the we call as the 4th layer also. But about the physical and application layer, moreover same. See the physical layer where the sensing and the actuation is happen. In the physical layer, it's called as a physical layer where the sensors, actuators, sensors like as temperature, vibrations, pressure, RFID card, actuators like as motors, valves, cranes. So these are the coming to the actuators. These are coming into the here. So from that, the input is given. The sensor takes the input from the respective environment and gives to the through this communication to the computational layer. So what is happening in the communications layer? So the communications layer, it's support for the communications. The input are passed to the computation. That's why it is called as a communication or the communication network layer. So here, the industrial IoT plays the important role. Previously, IoT, now the extension of this one that is called as the industrial IoT network. Also, we can use the Wi-Fi, 5G, where the protocols work into that one, MMQT. There are the different protocols we can use for the communications. And through these, the protocols, the data is passed to this computational layer, where the computation is happening. So the computation is the conversion, converting into the input to the output. So through the some technique like as a digital twins, I'll talk what is the concept of the digital twins, the artificial intelligence algorithms, machine learning algorithms, that algorithms work in this the computational layer and convert that the input into the actuators. So these actuators comes into that one in the applications layer. And when you're moving into that, the data is stored into the data layers. It is called as a data and service layer. Data stores into the somewhere into the cloud, or maybe into that one somewhere into the edge computing devices also. Then after that, it's given to the applications layer. Application layer means where you are the exactly your the applications change your the positions. Let's take the typical example of the smart robot. I'll explain with this the layer. Let's a typical example of the smart robot. Robot want to change their the motions. So now change their the motion into that. The sensor takes the inputs. Let's the robot want to clap. So first, what into that the robot understand the some input as a voice. Some of the good news into that one. Now the robot want to clap into that one. The input is the voice, and then that input is converted into the binary, and that is given to these computational devices through this the communication layer. Less the communication layer is the IoT device, or maybe into that the small Wi-Fi 6 or the Ethernet, and through that is given into the computational layer. In the computational, so there is a microcontroller, or is some sort of the device is present that is called as a processor, which takes that the input and take into the action, and that action may be somewhere stored into that some devices. And when this action is given passed to the actuators may be present into that in the robot. That can actuators means that's placed into that your the robot arm, and that can clap that the that's hands. That's the one example. It coming into that the applications layer. So here the different layers with the different devices are the present. If you explain into that the very lower level, so this is the typical example into that one. Where is the cyber and where is coming into that the physical space? So here already I clear into that one. This physical and the applications layer are the same. So the physical and the applications where the sensing and the actuation is happening. The same, it's here in the physical devices. The computation is happening here. So where is your the computations, and the data is stored into the some local site or maybe onto the central site, and this the communication is happening through this ICT, information and communication technology. These are the physical components where the sensors are the presents. Through that the sensing and the execution is happening. So this is the typical architecture of the cyber physical system. Now when you're developing any cyber physical system, how you can model into that? So that's called as the modeling as the cyber physical system. So if we see the software engineering, there are the different modelings are the present: waterfall models, V models, spiral models. But here something the different modeling in the cyber physical systems. It is completely work into that the feedback based system. So the cyber physical system work into that very fundamental is called as a theoretical modeling. The very fundamental into that one, the theoretical modeling, where the mathematical models, logical models related to that application first develop onto the paper. If you talk about the typical example of the smart home, then let's understand into that one for the smart home. So what exactly you are controlling? Are you controlling energy? Are you controlling into that the machine? Are you controlling the security? Are you controlling the some sort of the fridge, or maybe into that cooler or AC? So for everything, so first you have to define the theoretical modeling. First you understand there the input, output, and how to you can make it onto the paper. And there is some mathematical equations you're supposed to first create for that one. Then when you are comfortable from the theoretical modeling, the next part is come into that the designing. So in the designing, we supposed to be from the input to the output. So what sort of the input is coming? Input is given to the which devices. Output of these devices is given to the input to the next. Completely the data flow diagram supposed to be come into that the design. And when designing that one, you have to take in consideration of the software, hardware, as well as in the hardware, especially when you talk about the sensor, which type of the sensor is present. So that you have to clearly mention, especially when you're designing. And when the design phase over, the next part is coming to that the simulation. Simulations is totally different in the cyber physical system. Simulation, here the first simulations, you have to work for the one autonomous system. For example, I am making the autonomous system for that smart home, especially for the energy. Second, I'm building one of the for the networking, how the objects are communicate to the each others, and how the communication is happen. That is called as through the network simulator. So this is one of the simulations. Third is another for the applications, another one of the simulations I am doing. And after that, we have to integrate all the simulations together. So that is called as overall simulations. And in the overall simulations, we have to see how the cyber physical system work for that the applications. That is for the smart home. The next part is coming into that one, develop as a prototype model. The prototype models, without deploying into that one, you create into that one small environment. You test it into that one. Can all these autonomous systems are work properly? Can sensor work properly? Can action is happen the properly? And if everything is properly work with the prototype model, then that model converted into the final model, and that deployed into the field. And after the deploying, that is also not a final. Then it should be adaptive into that the environment, because the CPS model should be adaptive and intelligence in natures. So after this deployment, there is happening fine-tuning. Fine-tuning into that one, there are some changes into weather, some changes into the environment. Then that feedback, it's again give into that one the prototype models. And that prototype models again changes into the final model, and these final models again put into the applications. So right now you have seen into that the 6 phases, but actually there are the 8 phases. So this is the fine-tuning application. Then after that one, it is called as a feedback. So according to the feedback, changes happen into that the prototype model. Again, that the prototype model converted into the deployment, and then again deployed into the field. So like that is the modeling is happening in the cyber physical system. Take the typical example of the smart city. So with these the different phases of the modeling. So the first is coming into the identify needs. So already I given into that one. The different applications are there. For example, to traffic management, energy management, then weather management. The different applications are the autonomous applications are the present. You have to find the solution for the individuals. Then develop the prototype models for the individuals. Then you conduct the test for that one. Then implement into that one. Then monitor the performance, take the feedback. According to the feedback, refine the process. And after that, you can deploy that onto the field. So this is completely changed. These are the 8 phases normally work when you develop the model for the cyber physical system. Research trends in the cyber physical system. As already I mentioned into that one, cyber physical system is extending into the industry 5.0. Already that concept start into the European country. So then what are the new trends into that one? So where you can do some sort of the contributions, where we can do some sort of the research contributions for the different applications. So the first research trends in the CPS is artificial intelligence driving autonomous decision making. When you talk about the AI driven autonomous decision making, the concept is coming think, learn, and act. When talk about the autonomous, the concept is coming that is called as the think, learn, and act. In the existing cyber physical system applications, the autonomous decision making is struggling. Why it is the struggling into that one? For example, if you take into that one for the aircraft, still we are finding the different faults or the different issues in the aircraft, or especially into the drone technology also, because the existing algorithm that are used into the cyber physical system, they are not giving as a proper solutions. So when you're developing any autonomous decision making, so the new algorithms supposed to be required, which can help for the fault detections, which can help for to adaptive decisions. Seeing the past experience, the system work automatically. Try to help to overcome for the uncertainties, and for that one, a new idea in the reinforcement learning, it can help it to develop this the autonomous decision making. If some of the new algorithms, some of the new idea comes through the reinforcement learning for the application, for the medical, for the related to the robot, or maybe related to the aircraft, so that can be the great contribution in the cyber physical system. Next one is called as a digital twin technology. This is one of the new trends in the cyber physical system. What is this digital twin technology? Creating the virtual model in the physical system. That's why it is called as a twin. This helps to synchronize the physical system with the virtual system, especially in the manufacturing system and the medical system. This is very much required. So when you're developing into that one, the virtual models, and the virtual models can work just like as a physical systems. As a one mirror image we are creating for that the physical systems. That helps to the users, or maybe into that the human. For example, you take the help of the robot surgery. From the somewhere remote places, the surgery is happening into that one. But how the surgery is happening, if create one sort of the virtual model at to the local place where actually the communication is happening. So then the doctors, maybe that who is executing that whole the process, it gets as a confidence that the things are happening in the right directions. Same in the manufacturing also. So the digital twin technology, it's one of the new trends in the cyber physical system. Next one is the sustainable and intelligence infrastructure. This already you are familiar. So sustainability, it's a very important concept now into the current scenario. Any system, take the example of this, the smart city. You can develop as a smart city, but that smart city should be sustainable. If something uncertain happen into that one, some sort of the earthquake is happen, some sort of the uncertainties happen, at that time sustainability should be maintained. So seeing that one, how you can develop that the cyber physical system. So that is one of the important contribution will become into the future, that is related to sustainability and the intelligent infrastructures. Especially if you see into the Japan plays the very good research, especially into the sustainability and the intelligent infrastructure. Many earthquakes are happening into the Japan. In the weekly or quarterly, the earthquakes are happening, but still they are sustainable, especially for the infrastructure, because they taken the help of the cyber physical system and they develop the infrastructures. Next, the secure communications and the cyber physical system, cyber security. So here, the security is a very dense area. The cyber security, or maybe as a secure communication, it's a completely dense area. When you build the applications, there are the threats, vulnerability are there. Ultimately, somewhere some are given the solution, and when you give the solutions, again there will be some threat will be present. So that's why it is completely dense area. So this security is still, when you have the applications, we have to give the solutions. When you're doing the next version of the applications, we have to use the new threats will become, new vulnerabilities is come, new solutions we have to provide. This is the no end for that. So you can give the more contributions, especially into that the cyber security. And the next one is called as edge and the fog computing, that I'm trying to discuss into that one. It is one of the new concepts, especially in the cyber physical system. What happened in the cyber physical system, instead of sending all the data to the cloud, cyber physical system use the edge and the fog computing. Every time it is not possible to that send all the data to the cloud. So what they're doing into that one in the edge computing, processing happen to the near devices, that is called as edge computing. All the processing is happening into the edge, into near to the device, that is called as edge computing. And the fog computing, the computational happen in between to the node and to the edge. So, or sometimes the computations happen in between to the node and to the cloud. That is also called as a fog computing. I'll give some example of these, the edge computing. For example, edge computing, you talk into that one into the smartphone. In the smartphone, there are the different applications we are loaded into that one. Typical applications into that one. How many steps you have taken walk daily? That applications maybe you downloaded into that one. So what happened into that edge computing? Ultimately, when you are not up to that particular the thresholds, some sort of the pop-up will come into that one. So that's called as a edge computing into this. What is concept of the fog computing? Take the example of the smart city. In the smart city, the fogs are collected. So one fog is present into that collects the data from the traffic sensor, or maybe for the traffic sensor, or maybe from the light, and to optimize that one. So every time, especially when you talk about the fog computing, not to the data supposed to be go onto the cloud. So there is edge and the computation happen, and ultimately you give the decision into that one. When you talk about the manufacturing sector, this is the fog computing plays the important role. Every time data are not supposed to be sent to the cloud, there is ultimately one of the computational devices present in between the edge and that particular the local device, and the computation is happen there, and that concept is called as the fog computing. The basic advantage of this, the edge and fog computing, to minimize the delay. The processing supposed to be happen fast, locally or middlely. That is the concept of the edge and the fog computing. When happen the locally, it is called the edge. When happen to the local and to the central level, into the middle level, that is called as a fog computing. There are some issues into that one, but that issues can be overcome as with the different applications we are getting. For every application, there are the different issues, but that issues can be overcome when you are systematically treating this edge and the fog computing. If you take into that one, the example of the edge computing, especially for the robot surgery. So the decision are taken onto the local places because the doctors are available into that one to assist to the robots. So that's the one beautiful example of this, the edge computing. So these are the different trends into the cyber physical system. So extension of the cyber physical system. Now in the era of Industry 5.0, the cyber physical system extend to the cyber enterprise system. Previously, just we call as a cyber physical system. So where we can give the solution into the mechanical, optical system and electrical system. But now the concept, the extension is happen, the cyber physical system to the enterprise system, especially for the business model, for the service process and the operating models. That concept is called as a cyber enterprise system. Also, cyber system or the cyber physical system extending to the medical field, that is called as a cyber biological system. So where it can be medical or the biomedical systems that work, the different applications, different issues we can solve in that the domain, that's called as a cyber biological system. One more into that one, the cyber physical helps for the governance also, as well as for the monitoring the education, monitoring the healthcare. So that is called as a social system. That is called as a cyber social system. And such type of the applications also available into the public domain. So that's one of the new era that is called as a cyber social system. So these are the different extension of the cyber physical systems. Now we'll see, I'll end the presentation with the small case study, how we can develop as any small applications in the cyber physical system. So let's understand to develop the smart thermostat system for effective
Good evening, sir. Sorry to interrupt. Can I ask one question in between, or should I wait till the session end?
Yeah.
Can I ask, sir?
Yes, please.
Sir, I have two questions. First, in the previous slide of this one, then this one, sir. Sir, here sustainability mean about the infrastructure or about the systems that we are using? That is the first question. And second question, sir, in edge computing, are we using the existing computing power of the devices like mobile, or we will have to install some other computational devices for doing the edge computing?
Yeah, thank you,
Or will
madam.
it be application based?
Yeah, thank you. It's good questions. The first, when you talk about the sustainability, ma'am, sustainability, it's talk about it's the both into the hardware as well as the infrastructure point of view. When you talk about the sustainability, first I'll talk about related to the software. So sustainability, sometimes we are not considered the some constant, or we can some conditions when you're developing some sort of the software. So that if some sort of the attack happens, if some
But
sort
if
of,
in that case, if we are preventing or managing any cyber attack, that would be considered as sustainable?
yeah, and that should be into the scalable also. If some of the more users are the presents, the more nodes when you connect it into that one. So my system supposed to be sustainable that particular the load.
Okay, because at times system diagnose some malicious software or some attack automatically. Means that system is sustainable, we can say.
Yeah, but see, every times the new threats, new attacks is the present. So when the new attacks will become, new threats will become automatically systems adaptive into that one and give the proper secure or we can call as a sustainable across that particular the attacks. The system should be into that the work, seeing into that the previous experience. That is come as a sustainability.
Sir, apart from the cyber threats, can we cite some other example regarding sustainability? If you can please,
Sustainability,
sir.
let's take the example of the energy grid. Take the example of the energy grid into that one. Sometimes the more load will be there. Sometimes the let's we are to optimization of the energy grid into that one, where energy optimization, sometimes the load are the more, sometimes the load are the less.
Right,
So when the
right.
loads are the more, at that times my system supposed to be sustainable. Somewhere my some my the node should be off, some my node should be on. So it's not should be goes into that one the break my the system.
Sir, we can say that power optimization can be achieved using sustainability.
Yes. That is the example of that and the power optimization into that. Clear.
Okay, sir. Okay. And about some edge computing, if you can just elaborate that, do we need a traditional computation system?
See, edge computing is the concept of the edge computing into that the processing happen near to the devices. For example, when you take the example of the robotic surgery. Robotic surgery, if some of the surgeries happen, and when the computation is happen onto the some central place or maybe onto the cloud, so then will be so much delay will be there. So
Right.
whatever the devices is present, there is some device is present onto the device, the computation that the whatever the control system, the algorithms that's supposed to be happen onto that device only. That is called as
So,
edge computing.
so for that, we will have to install some additional computational devices or
You
computational.
are definitely some of the devices you have to install into that one. Also with the some algorithms, you have to embed some of the new algorithm in that the devices, and you have to keep it near to that the node.
Okay, like as you cited the example of some health tracking apps, so they pop up that you are not doing something or your steps are less. So that is, in that case, the mobile itself is using its computational power on a smaller scale. But if we consider it on a larger scale, so we will have to install some other computational devices, right, sir?
Correct, madam. Correct.
Okay, sir. Thank you so much, sir. Thank you so much.
Thank you. So this is the extension of the, now I'll take one of the case study to develop the smart thermostat system for the effective heating, ventilations, and air conditions control. See, now into the public domain, there are the many thermostats are the present, but each one having the pros and the cons. So whatever the case study I am taking into that one, each also having the pros and the cons. But when you're developing as a smart thermostat, what are the steps supposed to be take care? So that I have taken into the case study. So the smart thermostat represent a significant advancement in the home automations and the energy management. The basic objective of these one for the home automations and the energy management. What is previously a traditional thermostat that simply maintained the fixed temperature? So that is a completely fixed temperature. That's manual interface is the required. If you have to control it, you have to do the manually. But in the thermostat, smart thermostat, use the integrated sensors, connectivity, intelligent algorithm to learn the user preference, adopt the change in the environment condition, and optimize the overall energy consumption for improve the comfort and the efficiency. See, what's the ultimate goal of these to develop as a smart thermostat? To optimize the overall energy consumption and improve the comfort and the efficiency. So when you're developing this is the objective when you're developing as the smart thermostat. When you're developing into that one, so these are the 4 steps I supposed to be designing into that one from the my view. The very first one is the design principle. When you're developing any thermostat, smart thermostat, what are the design principles? What are the new algorithms you are supposed to be taken care? Then how you are doing that, the simulation of that one. And the last one is how you're developing the prototype models. So these are the 4 steps when you're developing any particular case study for the cyber physical system. So the first is design principle. So design principle for the smart thermostat is the remote control. I can control my thermostat through the mobile. I can control my thermostat through some devices, that is through the remote. So learning capabilities, my thermostat can learn. So the usage of my whole particular environment, and schedule the temperature according into that one. What are the temperatures currently present? And according that, the thermostat supposed to be work. They can be max or the mean also. Then it can dictate the occupancy, how many people are into the home right now, and adjust the temperature accordingly. Then also it's a weather integration. It's predicate the weather if there is the rainy season and maybe not the rainy season. According that, it can adjust the temperatures. Most about the energy reporting, report the energy usage. And the very last one, that is called as smart home integrations. Can other part of like as a light, fan, everything, can I integrate into the thermostat? So these are the different points I'm taken care when you're developing into the smart thermostat. So then when you're developing the thermostat, then the designing part will become here. What are the hardware part? What will the software part? How you are the user experience? And how you combine all these together into that. So when you talk about the hardware components, so different types of the sensors will become temperature sensor, humidity sensor, occupancy sensor. They definitely will require microcontroller. Then definitely we require some communications modules. So many hardwares are required into that one. At the same times, we require the different software also. Operating system. For example, when you work into that, when you have to operate into that, the real time, that is called as real-time operating system. Different communication protocols. You have to choose some sort of the architectures where the different protocols are the come. HTTP, SMTP, that's all the protocols which come. Then also we require some of the memory where the data you have to store. So what type of the structure of the data, that also you have to decide it. And the very important into that, how you are the graphical user interface, that is called as UI, user experience. So you are the user experience easy to understand because when the outcomes comes to the screen, that easily to understand. And at the same time, the interface also. So how, for example, I'm working through the mobile. So my interface supposed to be there. That is called as UX UI designing. So that supposed to be. So these are the different components you have to take care when you're developing as the thermostat. And these all are you have to integrate. So when you're developing the thermostat, the most important part is the algorithms. Because as already I clear into that, the many thermostats are already available. Some are the smart, some are the not smart. But the smart thermostat also having some pros and the cons. Why? Because they're not properly choosing the algorithms, or maybe that the algorithms not work properly. So if you talk about here, the first is come as a PID controller. That is called as a PID controller is the professional integral device controller used for the feedback control algorithm, because whole the system is work onto the feedback system. What type of the feedback is goes to the sensor, according that the microcontroller change that the positions, change that the action. The next one is coming to the learning algorithms. So I advise into that one, or I can suggest into that one, the reinforcement learning are the best algorithm for the cyber physical system, because these completely work onto the feedback systems. Then again, there are the machine learning algorithms which can help for the pattern classifications. So that's algorithm somewhere you have to use it. Scheduling algorithms, like for scheduling all the tasks, rule-based scheduling, adaptive schedulings. And the more about that, the optimization algorithm, genetic algorithm, simulated leveling algorithm, there are the many algorithms are the presence. You can choose into that one. And from that, we can build up one of the optimal temperature control smart thermostat. So these algorithms, you have to integrate it to each others. It's not one algorithm, one input into the givens into that, the next one. So the input of one to the output of the next, output of the one is gives to the input of the next, and then you have to integrate it into that one. Because here, when you talk about the smart, it is more complex when you take as the more applications. Each one has the individual application. For example, if you talk about these, the occupancy detections, when you are talking into that, the energy reporting. So the different applications, when you put together, then the different inputs are the coming. And that input you have to give to the controller. So the optimum when you're doing as applications, the up to what level you have to make it as a complex, that you have to decide into that. Then when you're doing as a simulation, because I'm not explaining all the algorithms in depth, just I suggest which algorithm you're supposed to be used when you're designing as a smart thermostat. Here, as already I clear into that one, the simulation is totally different when you're designing into the CPS system. For example, the energy simulations tools, when you're doing as energy simulation, these tools are using Energy Plus. When you're doing as a power system simulation, we are using as a Power World. When you're doing as the simulations of my reinforcement learning, I'm using somewhere the MATLAB, Scilab into that. When I'm doing the simulations of the network, that is called as the communications into that one, then I'm using as NS4 or Ominet Plus. And then all these simulations together, we have to combine, that is called as the overall simulations. So in cyber physical system, the modeling paradigm of different domain need to talk among each others. So that's why the simulation, it's somewhat the difficult or the harder when you're doing in the cyber physical system. So the different simulations, we have to first check it, and then we have to integrate it together. And when you integrate it together, we have to go for the prototype. You have to test it with the time, with the thermal capacitance, with the heat input, the heat loss, and how the room temperature is matched. When you create the prototype models, and these prototypes, when you build up as a overall simulation, these overall simulations, you have to test it with the time, with the thermal capacitance, with the heat input, heat loss, and how your the thermostats work. And if it is work perfectly, you convert into the model. So that is called into that the prototype model. And with the prototype models deploy into that one. In the deployments, again goes into the feedback systems. And with the feedback system, my system supposed to be learned and gives as a better solutions to that as per the environment. So like that, system is work for the cyber physical system. So what is the important learning into that one? Especially for the current case study, the smart thermostat demonstrate the modern CP integrations combine sensing, computational actuation for the intelligent control. So the future enhancement include the AI, digital technology, and so on into that one. You can include into that one whatever the research trends we have discussed. Using that research trends, you can develop the better smart thermostat. Ultimate goal of the cyber physical system, or that when you're developing as a smart thermostat, it must be exhibit steady behavior in all the situations. Use the current technology, develop the new algorithms, use the enhancement into that algorithms, and using that the enhancement when you're developing as a smart thermostat, this should be behavior study in all the situations. So that's the important learning from this the case study. So that's the end of my presentation. These are the references which I have taken the inputs. So these all are the journals. If some people want to do the research or maybe explore the learnings, so please refer there. These are the different journals are there, up to these all the journals. And last one is the book that is called as the Cyber Physical System by Fee, by CRC Press. Very beautiful book. It's openly available into that one. And these rest are the journals where the current research in the cyber physical systems will get it. So that's all from my side. If any questions from your sides, so we'll discuss. I'm ready for discussions on your the questions.
Thank you, sir. Participants can ask questions. If you have any queries, you can ask. Unmute yourself and ask questions.
Hello, Subhash sir.
Hello, sir.
Shafi Pathan here.
Yes, sir. Please.
Any practical example of CPS is implemented around in Maharashtra or nearby to us?
Yes, sir. The typical example of this one in Indore. Indore, especially for the waste management, and for the water control. It's the best example of the cyber physical system. In the Indore, they have taken care about that one.
Achha. Okay, sir. Thank you.
Thank you.
Any other participant? You can post your queries in chat box also, or you can unmute yourself.
Thank you all. Thank you for your patience. If there is no query.
Thank you, sir, for sharing your valuable insights on overview of cyber physical system and its role in modern technology. It's very informative session towards who wants to start journey in the field of CPS. Thank you so much for giving your valuable time, sir.
Ma'am, I would like to add one thing.
Yes.
I was overwhelmed
continue.
by the abundance of information sir has provided. I am very thankful because I got to know so many new things. Thank you so much, sir. And
Thank you,
I
thank you.
request if this PPT can be shared, that would
Yeah,
be of
sure,
great
ma'am.
help, sir.
Sure, ma'am.
Thank you so much, sir. Thank you so much.
Thank you, sir. Participants, I am going to share feedback form link in the chat box. Kindly fill it. We'll start our session 2 after 5 minutes. Please stay in the meeting. Thank you.
Okay. Thank you, ma'am. Can I stop the sharing?
Yes, sir. Yes, sir.
Okay. Thank you.
Thank you.
किचन में तो देखिए क्या हुआ भाई। कुछ नाश्ता किए हैं कि नहीं?
रास्ते में क्या चाय बिस्किट खाएं।
Kindly mute yourself, participants. The second speaker will be joining and we will start the next session.
Ma'am, I joined in the call.
Okay, okay. Okay, sir. We will start. Yes.
Let us know when I can.
Yes, sir. I will let you know. Just a minute, sir.
Good evening, Ravi sir.
Good evening, ma'am. Good evening.
So today's session 2 expert speaker is Ravi Prakash sir. He is a senior vice president and group security assistant leader at Geo Platforms Limited. His role, he leads comprehensive cybersecurity initiatives spanning customer analysis, application security, application design and architecture security, DevOps with shift-left automation, identity and access management, public key infrastructure, as well as AI security and data security across platform. He is a cybersecurity leader with over 26 years of experience in shaping enterprise security strategies, elevating digital trust, and delivering secure, scalable products and platform. Ravi sir previously held leadership positioning including Vice President, Informative Security at Reliance Jio Infocomp Limited and Senior Security Architect Lead at Microsoft, where he played a key role in enterprise security architecture, privileged identity protection, secure product design, and threat-driven governance. His work enables organizations to proactively mitigate involving cyber risk while sustaining business agility. His impactful contributions to the cybersecurity community have been widely recognized. He has been honored with CISO Forum AI Visionary Security Leader Honorary Awards, ETCO Award for Excellence in Secure IT Automation and Technology Transformation, CISO Mentor Jury Award for Leadership and Community Advancement in Cyber Security. His interest is secure solutions and embed security in all existing and new innovative product line. Thank you, sir, for accepting our invitation. Please continue with the session.
Thank you, ma'am. Thank you. Thank you so much. It's a privilege and honor to spend some time and share my knowledge or share my experiences with all of you. Okay. Without any further delay, I assume we have about 1 to 1.5 hours. Is it correct?
Yes, sir. 1.5 hours. You are having 1.5 hours.
Okay. Okay. Are you able to see my screen?
Yes, sir.
Is it full screen mode?
Yes, sir. Yes, sir.
Okay, great. Thank you. I just want to make it as an interactive session. If anyone has any questions or any doubts, please feel free to interrupt me so that we can have a more engaging conversation. Quickly, I just want to have, this is the very high level agenda. I plan to have that introduction, architecture, threat landscape. In this structure, I want to cover about how we are evolving about the security in cyber physical systems for a resilient future. Okay. Quick introduction. We already heard about me. Thanks for the professor for the introduction. This quickly about myself. Right now, I'm heading a couple of practices in cyber security domains in geo platforms, application security, architecture security, identity and access management, and PKI, and now recently AI security as well. That's what I'm trying to dig there. Yes, I will defer that, and some other time we can have a conversation around that. Let's come back to this one. How many people are familiar about the OT security? Have you heard of OT security? Okay. Yeah, operational technology, as you know that in industrial, in industries, in various critical systems where, like, for example, Jamnagar, or for example, electricity board, there are grids. There are many places where they do the control systems, where they do the manufacturing industry. That in the old days we do call it as operational technology systems. Now with the advancement of it, more about towards the connectivity and having interconnectivity and making sure about that people do operate from remote locations, and we have to do that. It is the next evolution of the OT systems to the CPS. Okay, where we are integrating the computations, where we are integrating the networking, because earlier in OT systems, it is totally isolated. If we are, I hope, shall I give an introduction about the OT side? You can type in the chat window if you want to have little this one, so that I'll give a quick overview about the OT security and then come back here.
Just give a introduction, sir.
Yeah. I have a comparison study at the end. I put that, so that we'll try to have that, so that. Can you see my screen now?
Yes.
Yeah. Primarily, the OT security is SCADA systems. We always hear about it. The primary focus about within the physical premises, how we are managing industrial equipment. That equipment can include mechanical or electronics or physical, any system do that. And limited connectivity, they will be having isolated network, there will be having isolated operations team will be there. That is about operational security. In especially in cyber security, in cyber physical systems, it is more about more computational. If you want to use GPUs, or if you want to use integrate with the IoT systems, or if you want to connect to our different locations, and that's where the extension to the traditional or existing systems, we are moving towards the cyber physical systems. As an example, smart grid. As an example, autonomous vehicles, smart cities, where people want to monitor about the progress on the municipalities, progress on the electricity, progress on the roads, progress on the IT infrastructure, progress on the healthcare, different innovations, what we come across as smart cities, everything has to be interconnected. Starting from in the healthcare department, the physical equipment, the diagnostics machines, that has to give the data points, and that has to go to the cloud. And IT department, operations team, call center team, they have to use different systems to monitor the data attributes. And somebody has to monitor closely, and they have to do about that. Video surveillance, traffic monitoring system perspective. There are many technologies, many use cases is going to do that. It is tightly connecting from the IT and OT and future next generation interconnected systems perspective. That's where the word is getting popular, cyber physical systems. I'm not reading out, the slide will be circulated with you so that you will be familiar about that. Okay, it's in OT, the typical components we may have heard of the SCADA, PLC, controllers, DCI, RTU, industrial sensors. In CPS, we do see the sensors, IoT devices, robotics, okay, smart sensors. And in robotics and smart sensors, continuously AI-enabled models will be there. And intelligently, it has to, based on the data points, it has to react. It has to do about that. In autonomous systems, let's say autonomous, let's say you may heard of that. If you go to the different hospitals, now they do have a different packages. Okay, manual laparoscopy or robotic laparoscopy. There is a difference is there. So the doctors are also leveraging the robotic way. In the robotic way, there is an AI they will be using about that, and remote control operations will be doing about that. It's an advancement, so it is inevitable. We have to interconnect, and we have to use the networking, and we have to enable the physical processes together, so that we will as a country, as a private sector or public sector, we have to move towards that. Okay, and in operational world systems, operational technology systems, the safety and availability come into top priority. In coming to the cyber physical systems, more or less indirectly, we are exposing all our systems directly to the public domain. So along with the safety, along with the availability, confidentiality, integrity is also very important. It's very high level separation about that, where we can see about that. Okay. Feel free to interrupt, as we are remotely virtually connecting about that. I wish to have that you are following what I'm saying. If in case anytime, feel free to do that. It's more about integration of computational networking and physical processes. Example, smart grids, as I gave an example, healthcare devices. Okay, tightly coupling between the cyber and physical worlds. Okay, sometimes people in OT side, people deny, no, there should not be any connectivity from my industrial premises to the IT. Okay, or they will demand about that, I wanted isolated network. But in the CPS transformation, it is very difficult to separate out that. Okay, why it is why this CPS security matters? Okay, as a example, smart grids. If there is any attack on a smart grid, what will happen? There is a huge outage will be there. When we have an outage, there are a lot of systems which are depending on the electricity. It will be on down, and critical systems, human, there are many huge damage will happen. So safety of human lives is very, very critical. And if it is related to the data centers, for example, or critical infrastructure from national critical infrastructure, towers, or defense equipment, or nuclear facilities, or many this one, it is very, very important that we have to take care of the national infrastructure protection. And if there is an outage, I will give an example. In Geo, because I'm part of Geo platforms, I'll give an example. During the COVID time, when there is a lockdown is there, 1 day or 1 hour outage will cost about 4 crores or so, something like that at the time, 4 years back, because every system is to onboard a new customer, or to do the recharge, or to physically visit the premises. Those are all lockdown. And no office is available, no Geo center is available, call center is at a dedicated infrastructure or specific office. People has to go to the offices to take the calls from the call center. Due to the lockdown, we have to think about different innovative solutions. All the call center people has to work remotely. If you have to onboard a customer, we have to onboard virtually. If you have to do the KYC process, we have to do the digital KYC. Why I'm giving the example is, if there is an outage, knowingly or unknowingly, there is a huge economical impact and financial impact will be there. If there is small outage on the NSC or SEBI or electricity board or this one, there is a huge reputation, there is a huge damage will be there. At the end, I will give some case study why, for example, in 2015, Ukraine power grid has caused a huge blackout in Ukraine. I hope you are understanding the criticality of the systems and how security matters in these systems. Okay, in a typical cyber physical system, there are at least 5 different layers will be there primarily. Okay, I'm talking about the at lowest layer. You take an example. You can imagine, you can visualize smart grid, or Jamnagar, for example, that one, or Tesla autonomous device, or connected car, or smart electricity board. You can visualize anything. There will be sensors will be there. There will be actuators will be there. The sensors will be running with a different proprietary protocols. The sensors will be running with a different handshake. These are not standard protocols. The communication is totally different. And those are all physical devices. Updates to the devices is very challenging as well. And we have to plan for those things as well, actuators. Coming to the cyber layer, next physical layer, cyber layer, especially the area where we have to worry about that, the controllers, the PLC controllers. Different algorithms, people use that. We have to worry about that. Efficiency of the algorithms, what the what cryptography algorithms they are using about that, encryption, decryption, cryptography. Are they using symmetric encryption? Are they using asymmetric encryption? At which models they are using that? Are they using a known, proven, tested models? Are they using in-house new recently developed on their own proprietary models? Are they using publicly available free models, Chinese models or US models, or some other fine-tuned models where we don't have visibility? If there are any hidden kill chain commands are existing within the systems, we are worried about that. In communication layer, when we have a IoT and computational and machinery and operational equipment, we have to communicate. Many systems will be having the wired communication will be there, and wireless communication will be there. So the protocols that we use within the wired, the protocols that we use in the wireless technologies, we have to worry about that. The wireless, it may be 2G, 3G, 4G, or 5G, or it may be microwave, or it may be electromagnetic wave. It may be any other communication layer. We have to worry about that, and we have to take care of the communication. If it is a defense side, that different technology will be used. If it is at home, it is different will be there. At a satellite communication, different communication protocols will be used. And the weakest link and the primary attack vector for any CPS architecture is our humans who do operate. Okay, this may be business operators, this may be the on-premises operation team, it may be managers, it may be continuous 24/7 operations team who will do follow the instructions L1, L2, L3 operations, and who do interact with the real users, and who do interact with the different systems to manage the entire CPS system as a platform, as a solution, as an organization. There will be a lot of solutions will be there, a lot of endpoints will be there, a lot of application will be there. For every application, it has to be operated. Every application, it has to be managed. There will be admin interfaces will be there. There will be configuration management portals will be there. There are a lot of, we have to worry about that, how they are connecting to the systems. Are they connecting on premises? Does they have a public IP? Does they have a private IP? If they have to remotely support about that, how they do about connect to the systems? That's where the matters. Human layer is a very critical piece of it. Why I'm telling human layer, once we give some examples, then you can make out that the reason behind that all vulnerabilities lead to compromise of multiple layers. One of the human layer is very, very important. The data flow from physical to the human, the perception, communication, control, activation, everything is important. Every layer we have to secure about that. Okay, and communication is important, control is important, activation is important. Here, when it comes to CPS, there is no where we cannot leverage, we cannot compromise anything. We have to strive towards 100%. We have to make sure about that known vulnerabilities are taken care, and segmentation is taken care of that. That's the reason we have to think about that in all aspects. Okay, let's coming to real in comparison to traditional IT systems. Okay, in CPS it is real time. Okay, if there is a damage on power grid, if there is a damage on traffic electricity, if the damage on automated car, if it is a damage on real-time healthcare system, troubleshooting system, healthcare operation system, there is a huge damage in real time. Safety is super critical. And that's the reason we need to have a high resilience. That's a topic what we have, that we need to have to think about that fault tolerant. We need to have think about that, how we ensure about that there won't be any impact while we are designing it, while we are putting into operations, while we thinking about planning to develop any system which is in real time, where it will be used about humans. Human lives are part of the journey, life cycle. When it comes to IT, it is focused on the when it comes to IT, it is focused more about the data. If our network is down, yes, there is an outage. There is a people will be get disappointed, but there won't be any human loss. Okay, it's more focused about the data. It's more focused on availability. It's more focused about confidential. I know all of us know about that. If there's an outage, if my WhatsApp is not working, it's okay. If my time sheets is not, it's okay. If my connectivity is gone, yes, it can be acceptable. But in the case of CPS, no, we cannot accept it. It has to be, we need to think about that models. We have to think about the different solutions, keeping in view of the real-time availability. And on the flight, for example, if something goes wrong, what will happen? You may heard of the latest, when our Tejas is participating in the Dubai aircraft, you know the latest incident. Yeah, it requires, CPS requires integration of safety and resilience with security. Why I'm highlighting about this particular safety and resilience is there is a lot of scope to innovate. There is a lot of scope to bring a lot of algorithms and resilience, bringing about that more maturity. 1 second. Yeah. I'm on other call, sir. Yeah. Hi, I'm back. Yeah, hi. It requires integration, safety, and resilience with security. I hope you are able to see the next slide. Yeah. The potential threats that we see in CPS is malware and ransomware. Okay, people try to inject malware to the end users. If you try to see this system, these layers, they try to inject malware in the human layer. They try to inject malware in the human layer operating systems. They try to inject any hidden code or persistent code within the sensors or actuators, and they can try to do any patch vulnerabilities via any supply chain modules. Okay, in the protocols also they try to hack about that. Okay. When they are, hello, any question from anyone? Yeah, people try to do, if they use the weakest protocols, if they're using any communication protocols which can be hacked, they can try to inject and try to break it and try to spoof the protocols and try to misguide the controllers and try to inject the malicious load and take charge of the control of the entire systems. And if they are cyberly interconnected and they are available in public domain, they are prone to DOS and DDoS. Okay, as we are using chips and as we are using electronic items, as we are using mechanical and different equipment, IoT devices, there is a chance that the data can be tampered via firmware or binaries or third-party libraries or kernel or a different way people can tamper the equipment that we use about that. And on top of it, as part of the this journey entire life cycle, people want to know that the people who are trying to do targeted attacks, they study. They don't try to hack our system in a day or two. They spend about at least 6 months, 1 year to understand the systems. They lure the operators, they lure the managers, they lure the directors, and they try to go acquaintance with all the people, all the systems, and try to study about that, what technology they are using. Are they using Apache? Are they using Siemens? Are they using Honeywell? Are they using this one? They try to study a lot of things and try to find the weakest link within the internally, and through the internal information, they can attract some data points. Using that data points, they can try to full-fledged, okay, they are using log4j, or they're using S3 bucket, or they're using some processor, microcontroller. They try to get some inside information. Through that, they try to attack our CPS system. And physical tampering, this is very, very important, because when we are having these particular systems, most of the systems will be interconnected with so many small hardware component and software component. Each software and hardware comes with a firmware, and each hardware will comes with the drivers, and the communication protocols will be having some drivers, and software will be coming with the patches, regular periodical patches. When we are having about that, we have to do the regularly periodical patches should be applied. When we try to do the patches, when we try to do the manually, people do use about that USB stick or try to replace one equipment, there is a chance that people can tamper it. Okay, while during the updates or during the replacement hardware, or try to do physically try to remove about that and add-ons about that, and by sitting on side by side jamming machine. There are many ways, many techniques people use about that physical tampering. And as I said about that, as an example, I'll give an example. In a mobile phone, there will be at least 300 to 500 hardware components will be there. And all hardware components will be relying on some software. Hello?
Participant, please mute yourself.
Okay,
Sorry,
it's not
sir.
question. It's not question for me. Okay, yeah. Supply chain vulnerabilities play the huge role here. Let's say if I want to build a system, CPS system, there is a dependency of a lot of OEM partners, lot of equipment, lot of software, lot of connectivity, lot of AI model. There are a lot of things will be there depending on the system what we are planning for it. As I'm giving an example, in mobile phone, there will be around 300 to 500 components will be there. Each component will be coming with some driver or some firmware component or something. I hope all of us use the Windows systems or Linux systems. When we boot the system, there are so many components, so many drivers, so many libraries will be installed in your system. And those systems will be regularly updated. If any of the component, there is a business is not doing good and there is no market for that particular components, obviously the supplier, the OEM partner, they don't provide the patches. We end up living with the vulnerabilities within the supply chain. This leads to a lot of known risk where we cannot replace it, because there are some occasions where we can replace it. The budget is there, they will grow and replace it. If there is no budget and they want to have a replace, they need a time of 6 months time and 1 year time. Even if they replace it, there is interdependency required, compliance come into picture. There are a lot of things come into picture. So supply chain vulnerability is very, very important when it comes to while designing, while building the CPS. And planning is important. These are the potential threat vectors that we see in CPS. Yeah, as I said about that, different threats. Okay, if there are any attacks, known attacks, threats is good. Okay, these are all possibility scenarios. Okay, what are is there any happened? Does any attacks happen? Does anyone exploited the vulnerabilities within those systems? These are some of the specific attacks that we have to worry about. That people do inject data injection attacks. You know about recently Israel has blasted mobile devices. Hezbollah, they are using about that. They injected some commands that will trigger one of the component, one of the firmware component, and it will activate and silently blast it. Okay, there is a false data injection because those commands are not any signature patterns. Those looks like a genuine patterns. It is very difficult for a monitoring system or any security 24/7 security monitoring system, SOC, NOC. It is very difficult for them to detect those. Okay, data injection attacks and sensors. When our equipment relies on some communication protocols, there is a possibility, as you know, recently there is a jammers happened in Delhi airport and some other parts of the other airports. There is they introduce the spoofing technique on our GPS. Okay, they try to inject high signal GPS signal and try to create a false trigger to the traffic controlling systems in the airplanes, and they are getting confused which one to believe it, whether the GPS location provided by the traffic controller or the spoofing controller, which one to detect it. They are getting confused. They are moving, rotating, and they are unable to land properly. And it's a huge jam. There are flights have to be cancelled. They have to reschedule. Recently, it happened. For example, there is a sensor spoofing will happen. For example, let's assume that there is an expensive car. We think about that. Let's say BMW or whatever we custom build. We build a sensor. We build a sensor where it will detect the incoming car or behind in the front car and back car. There is a sensor will be doing about that continuously. It is trying to do the location tracing about what is the distance, so that it will maintain the distance and give the input to the speedometer. It will give the input to the brake. It try to do the correlation about that to make sure about that it never collides. Okay, this sensor technology, I just want to give it this one. In 2003, I spent time in University of California and did the research work in the sensor technology. The idea is no two cars should collide. The investment, the research that we did in 2003 that got materialized in 2008, 10, 12, 13 time frames. That's the kind of research and innovation takes a lot of time. And when it comes to in reality, people try to, once we get about that, once some big guys took about the liberty and try to standardize the protocols and they launch about that with the Chinese or other low cost vendors, they will replicate it without thinking about that. What is the implication towards that? And when they release the counterfeit or low cost equivalent devices, people go and buy those things. And later on, during the operations, there is hacks will be there. People try to misuse those components. And we can control the when we try to run the commands, we can RCA, we can call it as remote code execution and privilege escalation, and we can do the control from the user segment to the root segment, or upscaling about the kernel level, so that we can take control about the entire hardware, so that we can make it as a jam, we can try to delay it, and we can do whatever we can do that control hijacking kar sakta hai. We can do that. And GPS jamming, as I gave an example. And as an example, Tesla recently, when they pilot about that 3-4 years back, there is a adversary, somebody is trying to hack that particular system, which is available within the embedded system. These have happened, real cases. Okay, that's what very high level I want to cover about that. Now I want to give few scenarios before jumping onto the strategy, going future study perspective. I want to give faculty or professors ask me to touch base about some case studies. How many people have heard of a Stuxnet attack? Yeah, in Iran. Hi, sir. Hi. Call by sir. Excuse me, I will take a 2 minutes break. Okay, 2 minutes, please. Yeah. Hi guys. Yeah, sorry for the inconvenience. Yeah. Can you hear me? I'm back. You can hear me now? Yeah. Hi. Hello.
Yes, sir, we can hear you.
Yeah. The Stuxnet is the. I hope some of you are aware of it. Let me go through that so that we'll come the year back. I'll just study about the case study. This is one of the successful cyber attack performed on the Iranian nuclear facilities back in 2010. Yeah, when we say state-sponsored, they will be having unlimited resources at their disposal. Hackers will be at their disposal, cloud will be at their disposal, DNS will be at their disposal, and writing zero-day vulnerabilities at their disposal. So they can keep on targeting about that, and they have a resources who will lure the personnel who is working on the facilities, so that they can interact with the socialize with the Facebook, Instagram. They can think about different ways to target the people who are working in the facility. And it's a 4-5 years efforts with a lot of money power, with lot of people involved, lot of spy agents will involved. People do target about that and study that and try to do that what needs to be done. And here in this case, they injected zero-day vulnerabilities on their PLC controllers. When they injected the zero-day vulnerabilities, they inject such a way that the operators, whoever is monitoring the equipment or devices, it looks like normal. But behind the scenes, they activated the hardware such a way that it will increase the speed, it increases centrifusion, and then it will lead to the blasting. And the moment when I try to trigger about that to do the physical damage, it's like a domino effect, one after other. By the time they release about that, it is too late to control about that. This is one of the first known cyber weapon designed to create real world physical destruction. Okay, attack vector is PLC logic. They try to target the PLC logic. And what is it? It is impacted some of the controllers they are using about that. And stealthy and highly tailored malware. Because there are a lot, they targeted many systems. It's not one systems, but they targeted all in one go. By the moment they got the confidence saying about that one system, second system, third system, fourth system, and then hardware as well, then they triggered it to activate it and they succeed about that. Okay, they don't have proper monitoring system, and they assume that they are not interconnected. Is the gaps, whatever the reasons behind that. Okay, I'm giving another one example. In US, there is a US pipeline, Colonial Pipeline, which is built long back, and they're using the pipeline pipeline system in multiple states. Okay, for this particular US crude pipeline ecosystem, people, they do control about this one via operators. Okay, the operator systems, the tool interfaces, the endpoints they use about that, they try to compromise the users and they try to inject the ransomware, malware, and try to take control of the system, and they compromise via the VPN account. They started by compromise VPN account. VPN account, it's a weak passwords. That's how they enter into the system and try to target the pipeline. When they started with the weak credentials, okay, the entire billing and operations are impacted. The pipeline is shut down. When the pipeline is shut down, the fuel doesn't flow to the different parts of the towns, villages, cities, and that lead to inflated prices, crude prices high, prices, diesel prices high, and gasoline prices are high. It's huge, and it's a panic mode, and government has to intervene in this particular system. What happened? The reason behind that here it is the consequence. They studied the research about that. The OT and IT, they are interconnected over the period. It did not happen one day. Over the period, it started with an isolated facility, and slowly to cut down the cost, to have the operators to do the billing, to billing the operations, to monitor about that real-time sensors. I want to know that what is my storage crude, what is my pipeline volume, what is happening about that. They introduce a lot of sensors, lot of operations, and try to do the remotely managing about that. And over the period, IT and OT are interconnected. And hackers has taken advantage of this particular status, and they disrupted this particular services. Okay, next coming to the another case study. Why I'm giving this different one example is here in the first study, they targeted about the malware and physical hardware and supply chain attack vector. Here they targeted about the weakest link, the user credentials. And here if you see about that, they don't have the multi-factor authentication. They don't have a segmented about their networks, Ukraine power grid. Yeah, Russian threat actors has deployed the malware, black energy, and killed us to disable systems, erase data, and delay recovery efforts. It's a huge outage to the Ukraine citizens, and there is a huge, these many people are affected. I hope you are getting about that. They try to target the operator accounts and try to inject the Trojan horse, and through that they penetrated about the move from one machine to other machine, and move from server to server and reach to the required power grid and hit the and created the outage. Any questions here? I hope I give the context, what is what is what. Now coming to this one is when we are thinking about to design, I already touched base about what are the required security controls indirectly by explaining attacks, by explaining threats. Now coming to when we are designing the new systems or reviewing the old systems or thinking about how to strategize our security strategy for any existing system or new systems. These are the basic things what we have to think about that. Our CA has to be there that, and we have to think about the safety as well. Safety is the super most critical when we are designing about the CPS system. You can see about the below definition so that people can relate to that. The modern systems where computing and physical world networking tightly integrated. And we have to think about the zero trust architecture. I hope all of us are hearing about the zero trust. The reason zero trust model is important is when people are authenticating, when system is authenticating, when service account is authenticating, when interconnected systems are authenticating, we have to follow the zero trust principle. Don't, even though you know that Ravi is getting authenticated, you challenge him again afresh. Even though Ravi is using his laptop, you challenge the laptop whether it's a genuine laptop or not. Okay, even though Ravi is connecting from Mumbai, you challenge him his location is same or not. Okay, even though he is using some of the tools and equipment to connect to the system, challenge the system at the service level, connection level. And when he is connected with the cloud, try to challenge it and don't trust any service accounts. We have to think about the zero trust model. And when you are connecting to remotely, don't ask them to prove it again and again, afresh. And as part of our design, as part of our interconnected systems, we have to think about the least privilege access. Okay, none of the system, whether the embedded system, whether Linux, whether it's Windows, whether it's a Docker image, whether it's a Kubernetes cluster, whatever you think about that, any tiny component, any system that we use about that, it's not run with a privileged account. It has to run with a released privileges. If in case, if any time it has to run with a high privileged account, we have to closely watch out that, how to handle that, how to, we should have a proper logging should be there and proper monitoring controls should be there. Okay, these are the basic fundamental principles. We have to think about that and we have to plan accordingly. Okay, there are publicly available frameworks are available. You can refer to that. I'm not including that. If required, I will include at least a lot of frameworks, lot of attack vectors are available. Primarily, you can think about that NIST and IEC and ISO. You can use different frameworks. Having frameworks is important and following literally those frameworks is important. Process is important, but technical controls, perfection of the technical controls, efficiency of the technical controls are very, very important here. Yeah, to quickly summarize about that, what are the security controls that we have to think about that? Identity and access management, it has to revisit it a regular basis, and we have to see that can we enhance it, can the protocols can be tightened it, are we rotating the passwords, are we using multi-factor, are we using the single factor, are we using the device, what you have, what you know, what you are you using a combination of different multi-factors or not, and how the technologies are how the session management is designed, whether sessions are strong enough or not. Are we using JW token? Are we using custom token? Are we using SAML token? Are we using OAuth token, OpenAI? All these things we have to revisit and try to see that, and we have to continuously try to see that, are we using what randomness we are using, random protocol we are using, entropy, are we where we are capturing the entropy, are we capturing from the devices, are you doing anonymization, randomization, are you increasing the randomization or not, what is the key size, is 128 bit, 256 bits, 384 bits, 512 bits, or 512 or 1024 or 2048 or 4096, asymmetric and symmetric, all these things we have to revisit that. And segmentation, when we have about that, different component, different layers, we have to at the cost of high performance versus security, if there is a trade-off is required, we have to do the logical segmentation. We have to create about that. Physical equipment has to be separate network, operations has to be separate network, users has to be separate network, and if in the interconnected system there are 10-15 systems are interconnected, we have to closely watch out that how they are segmented, what all protocols we are using about that. When we have a stronger design, stronger authentication, stronger network segmentation, we have to closely watch out that authentication logs, the system logs, different protocols. When it comes to CPS, it's not just like HTTP and HTTPS. There are a lot of legacy protocols come into picture, proprietary protocols come into picture. We have to use different tools where we can do the real-time monitoring and try to see that there are no intrusion, there are no detection. We have to do the detection controls on all across the components. Yeah. As I gave an example about that, what protocols they are using about that, how strong they are there. Are we using lightweight protocols? Are we using heavyweight protocols in IoT when we communicate with the IoT? Is the firmwares are upgraded or not? These things we have to think about that. Okay, are there because of memory, most of the devices will come with the very light, very small memory capacities. Okay, are the firmwares are happening regularly or not? Are OTT updates are happening or not? Is the OTT updates or firmwares are tested in test environment before deploying it or not? These are very, very important before planning these things. And keeping in view of the futuristic ready perspective, along with the traditional IT security systems, we have to think about the AI ML, and we have to use the different models and anomaly detection and predictive defense, so that we can combine the traditional security controls with the AI ML, and as we can try to do that and try to enhance the security posture of our systems. And these are the different things that we have to think about that. Yeah, as part of our system strategies, some of the strategies we have to think about that fault tolerant and redundancy. If one system is down or one controller is down, do you have a backup is there? One motor is down, do you have a backup is there? One system is getting updated, before updating to the master copy, is it well tested or not? Okay, if it is updated and after update after some time, there is a latency there is some other misbehavior which is not properly tested, can we do the rollback mechanism is there or not? Fail-safe designs are design incorporated or not? We have to think about different scenarios. How do we ensure about that? Starting from the simple command level, starting from the small equipment, even if it is 5 rupees worth or couple of $1 million worth, everything we have to think about the fail-safe designs. You heard about the recently a US aircraft which landed from the UK's aircraft landed in our this one. They're unable to fix it. They have to dismantle and they have to take the aircraft to the US. There are a lot of things where they do the kill chains. Many OEM partners, they embed the kill chain commands, so which is not known to the business people, not known to the operation people, not known to the who purchase them as well. Okay, we need to have the instant response business continuity plan. We have to challenge our OEM partners. If something goes wrong, what is my backup plan? Okay, do we have an alternative mechanism? We have to think about instant response. Are we prepared about that? We have to do the dry runs every 6 months, every 3 months. That's how we have to prepare about that. And security, we have to do the testing in all aspects. Whereas in IoT, whether it is IT system, whether it's physical system, all these things we have to think about that and try to think about that. In all these areas, there is a scope to innovate. There is a scope to R&D. We can try to bring the lot of new algorithms, new research to standardize the protocols, to think about different protocols and try to do standardize and do the integrate with the traditional SIM, SOC and NOC. The future of CPS security. Okay, going forward for faster and agile response, we have to think about AI-driven response. And people have to use, instead of using symmetric encryption and asymmetric encryption, which are heavy, which are slower when compared to the symmetric, we have to think about the quantum safe as well. And we have the libraries, the models, algorithms has to be quantum safe cryptography. They have to redesign about, they have to think about that. It's hardly another 6 months to a couple of years. People are going to be innovate and technology will be ready, and to break the traditional HTTPS protocols, traditional RSA or ECC algorithm protocols, it's a matter of time. People can tamper it and try to do that. We have to prepare ourselves. Are we using any cryptography modules? Are there quantum safe cryptography? Are we using it or not? We have to think about that. And when we are trying to move towards the 5G and 6G, the bandwidth, the speeds are pretty huge. We have to be ready about that, DOS and DDoS, how we have to handle these networks. And we have to think about that, when we are designing about that, are we following ethical standards? Are we trying to do the physical safety is considered or not? Are we compliant to the regional specific state level or country level or international level regulatory challenges? Are we considering all these things or not? All these things we have to keep in mind and we have to design that. Okay, this is a quick summary about that. There are gray areas. There are a lot of scope to innovate. There are a lot of scope to do about that. Is crucial for our national industrial personal resilience. Okay, safety is the topmost priority. Monitoring is the topmost priority. Thinking about resilient patterns and redundant systems are very, very important. That's how we have to move towards that. That's how we can secure our CPS systems. That's it. We already covered these things. Any questions and any? I'm more than happy to take any questions, any doubts here.
Thank you, sir. Participants can ask questions.
Yeah, good evening, sir. May I ask, ma'am?
Yes, ma'am. I can hear you, ma'am.
Yes, ma'am.
Sir, we were talking about the zero trust model, right? So
Yes.
in that, when we are doing it realistically, how is it possible? I mean, we have to do the trade-off between the delay or latency that has been caused because of this. So how do we take the call for the trade-offs between security and the latency?
Yeah, I will give an example so that you will understand. Okay, bring your own device. I hope you have heard of that. Bring your own device.
Yes.
And
Yes.
And because of recent lockdown and remote connectivity, we have to give a flexibility to user community and to do the cost saving to the business. People have to connect remotely as well. Earlier, they used to do traditionally connect about that. Okay, and they want to bring their network. In good old days, in previous generation, all the employees, all the workers, they work from the facilities, assigned facilities. Now, with the advancement of technology and advancement of social connectivity, people in many employers cannot deny not to carry their laptops, their personal gadgets. And along with the personal gadgets, Wi-Fi is available. Okay, whether I'm using my network or official network to download about that, and they can take the screenshots as well. So the traditional way to do about that, it's getting diluted. So what we have to do that, whether he uses personal device or company device, or he use about the location, the zero trust means about that we have to have a stronger authentication. Don't believe in them. That's what the first goal. Okay, when we are thinking about that stronger authentication and having about that multi-factor authentication, he may connect from his personal device, he may connect from his this one. We have to innovatively think about the different ways to do that. And for faster and performance trade-off, the protocols has to be enhanced. The protocols has to be enhanced. Okay, instead of using username and password and OTP, we can think about that OTP can be delivered, and there may be latency from the network side. So we can think about the secrets. Or Google authenticators, or different mechanism. We have to innovatively think about that, how to reduce the latency. Yes, I agree with you. Latency will be there. There is no second thoughts in that. That's why we have to use the advanced technology like a 5G. The bandwidth is pretty huge. When we go to the advanced 6G, the bandwidth is pretty huge. Instead of using RSA protocols, we have to go for the ECC protocol. Instead of using different, so it has to continuously, they have to innovate about that, they have to move towards that. As you know about that, 6 months before, the cost to use about in the AI models, it's $20 or $200 per month, per day. With a DeepSeek, how it is advanced, it is a $2 or 2 cents. We have to wait for that one for the efficiency and affordability. That's where the technologies has to be designed. And connectivities we have to use about that, lease line connection, MPLS connection, and we have to custom protocols, we have to think about that to achieve about that trade-offs.
Okay, sir, got it.
Yeah. There is no single answer is there. It is a continuous evaluation.
Right, sir.
In the zero trust model, don't believe the user. I'm using a company laptop. Still, you have to ask the password. You have to ask the fingerprint. You have to ask the OTP. That's the reason. Depending on the critical data function, we have to ask about, we have to demand that.
Yeah,
and wherever
that is what the question was about, the latency at the user's part. I mean, if at all they are not having 5G, or they are traveling somewhere, and then it will be always delay in the connection and the drop in the connection. So are there any standard protocols who can something regarding the caching part or having the security for that, pushing it to the cloud? Is there any latest protocol which we can work on?
There are, I don't recollect any immediate one protocol. In all areas, we can think about that. For example, SAML protocol, it's heavy. Okay, OAuth protocol, it's better. OpenID is little slightly different. JW token, they are little different. It all depends on which system we are thinking about that. And as you know about JSON data as well. what we are having about that different. Now the tune is coming to picture. For AI/ML, the tune protocol is there. Latestly, different standards, different technologies are coming up to override about that. I don't want to give explicitly one. Depending on the particular problem statement, we have to think about. For example, 2FA is not possible. We have to force them to use a complex password. If the complex password, still we have to worry about that. We have to ask them to rotate the password. Okay, even if we try to do about the complex password is possible, rotate the password is not possible, then we have to think about that where he can remember easily combination of a PIN, date of birth, other things are OTP based. It is depending on the situation we can do that. If required, we can have a separate connection so that to understand your problem, I will suggest the right protocols. I will give some references.
Sure, sir. Thank you so much.
Yeah, my pleasure. Yeah. Any other questions?
Any other participant want to ask question? I think, sir, no questions.
Yeah.
Thank you so much, sir.
Yeah.
You have explained real-time case studies which help us to understand working of CPS system in real-time applications, sir. You also enlightened us about the security in CPS system. So it's really very helpful session, sir. Thank you so much.
Thank you so much. Thank you. Thank you. It's my pleasure. I hope it was useful and productive session for all of us. Yeah.
Sure, sir. It's really very helpful.
Yeah.
Thank you, participants. Please fill both the feedback links.
Ma'am, I'm unable to open my chat, ma'am. Can the link be shared in the group, ma'am, or is it possible to share? The chat is I'm able to see there are 12 messages, but I'm unable to open it.
Okay, I'll share it in group. Okay.
Thank you so much.
Ravi sir, you can leave, sir. Thank you so much. Thank you. Tomorrow, participants, tomorrow you need to join at same time with same link. Thank you so much.
Thank you so much.
Thank you and good night. Take care. You may leave the session.
Thank you, ma'am.